The steel chrysalis, an engineering transformation. Phase 1. Site analysis and structural foundation. The project begins not with the structure, but with the geotechnical reality of the coast. For a seaside location, the foundation must solve two diametrically opposed problems: the corrosive nature of salt-heavy air and the instability of sandy, shifting soil. The pier strategy: instead of a traditional continuous concrete slab, which acts as a thermal heat sink and traps corrosive moisture against the steel belly, the team employs a point-load foundation. Using 4 reinforced concrete piers at the corner castings, the structure is elevated. This is a critical engineering choice. Shipping containers are designed to carry their entire gross weight through these 4 corner posts. By lifting the unit, we create a breezeway beneath the floor, preventing the ground effect humidity that causes rapid underside oxidation. To scaling and surface prep, the old container is a canvas of industrial trauma. Before any aesthetic work begins, the team performs a literal exorcism of rust. Using high-pressure sandblasting and pneumatic needle scalers, the oxidized layers and original lead-based marine paints are stripped away. We are looking for white metal, a pristine, porous surface that allows a 2-part epoxy primer to achieve a molecular bond, ensuring the steel can survive the relentless chloride attack of the maritime environment. Phase 2. Structural modification and reinforcement. Shipping containers are monocoque structures. Their strength is derived from the outer corrugated skin. The moment you use a plasma cutter to carve out apertures for floor-to-ceiling glass, you compromise the diaphragm of the box. The plasma cut: watch as the industrial torch slices through 14-gauge Corten steel. This is the point of no return. To prevent the roof from sagging, a phenomenon known as steel reinforcement, the team welds structural C-channels and HSS, hollow structural sections, around the perimeter of every window and door opening. This creates a subframe that redistributes the roof's gravitational load back down to the corner posts. The weather shield: we apply a dark, UV-reflective aliphatic polyurethane coating. In a seaside context, the sun is a thermal weapon. This coating acts as a mirror, reflecting infrared radiation while providing a non-porous barrier that seals every weld and seam against the ingress of salt spray. Phase 3. The thermal envelope: battling the toaster effect. Steel is one of the most thermally conductive materials in construction. Without a sophisticated thermal envelope, a container is a toaster in the summer and a freezer in the winter. Framing and thermal bridging: we install internal wooden studs, but they are offset from the steel ribs. This creates a thermal break, a gap that prevents heat from traveling directly from the scorching exterior metal into the interior living space. The insulation science: the gold standard here is closed-cell spray foam. Unlike fiberglass bats, spray foam expands into every corrugation of the container wall, creating a seamless, airtight seal. This is vital because it moves the dew point to the outside of the insulation, preventing interstitial condensation, the hidden moisture that forms against cold steel and leads to structural rot and mold. Phase 4. Systems integration: MEP, mechanical, electrical, plumbing. In a 160 to 320 square foot space, every millimeter is a battlefield. We move into the MEP phase, where the nervous system of the home is installed. Subfloor plumbing: because we elevated the container on piers, we have the luxury of routing the drainage for the bathroom and kitchenette through the original 1-inch thick marine plywood floor. This keeps the interior walls thin and maximizes living space. Electrical routing: home runs for the electrical panel are tucked into the wall studs. We utilize a centralized manifold system for plumbing and a compact breaker for electricity. Everything is converted to high-efficiency LED lighting to minimize the heat load on the HVAC system, ensuring that even in a tiny space, the climate remains perfectly tempered. Phase 5. Interior architecture and the infinite view. The final phase is an exercise in spatial psychology. We are turning a narrow, 8-foot-wide industrial box into a luxury sanctuary. Visual expansion: the choice of light-colored birch plywood and reflective white finishes is a deliberate architectural trick. By blurring the corners where the walls meet the ceiling, the eye perceives the space as significantly wider than it actually is. Biophilic design: the transformation is finalized by anchoring the structure to its environment via a cantilevered wooden deck. By building the deck flush with the container's floor, the living area is effectively doubled. Those large glass sliders remove the visual barrier between the resident and the sea, allowing the horizon to act as the final wall of the house. What was once a discarded vessel for global trade is now a permanent, high-performance monument to modern, sustainable living. Supplementary advice: The galvanic corrosion warning. Advice: when attaching different metals, like aluminum window frames to the steel container, always use a gasket or a specialized coating. A critical detail often overlooked is the risk of galvanic corrosion. When you marry aluminum frames to a Corten steel shell, you must use a neoprene gasket. Without this barrier, the salt air acts as an electrolyte, causing the metals to trade electrons and eventually weld or rot together at the seam. The off-gassing safety protocol. Advice: traditional shipping container floors are treated with heavy pesticides, like methyl bromide, to prevent cross-border pest transfer. Safety is paramount during the interior strip-down. Most industrial container floors are infused with harsh pesticides. To make this space habitable, we recommend either completely removing the original plywood or sealing it with. If you enjoyed this transformation, hit the like button and subscribe to Renovation Lab for more. Have a question about the build? Drop a comment below. I'd love to hear your thoughts. Thanks for watching, and I'll see you in the next one.